Kia ora Year 12. This video is a practice task for Level 2 Trig, and it's for students in my Level 2 Stats class and anyone else who wants to watch. So the task is called Hugh's Garden, and it's a handwritten one that I think we looked at in class, but I've typed it up here. So Hugh is designing a garden, and he's interested in figuring out how much space it's going to take up in his backyard. So we can assume he's got a reasonably large backyard. The first design is given below. So this is it here. And I just want to make sure that you can read that that number there is 26 meters, and this one here is 17 meters. Okay, we've got 20 meters here, and we've got a couple of angles, 94 degrees here and 85 down there. It's pretty clear that it's made up of two triangles, nothing particularly special about them. They're not isosceles or anything like that. Okay, so that's the first design. So after looking at this design, he thinks he'll have some room to add an extension. But he doesn't have too much space, so he wants the area of the extension to be 25% of the original area. Investigate the total area of his garden and propose two alternative designs for possible extensions. So I'm going to make two videos here. The first one is this one, and I'm going to just do this where I investigate the total area of his garden. Then in the next video, instead of doing two possible alternative designs, I'm going to do 4 alternative designs, and I'm going to do one of them first and then give you a similar one to do yourself, and then give you a second one and give you one for you to try. And that next video will be a little bit harder, but I'll go quite slowly. So let's look at what we've got here and think about all of the basic things that we've learned so far. If we want to find the area of a triangle, then we know that area is equal to a half AB sine C. So what I have to do to solve the problem here and find the total area is to find the area of the two triangles and then add those areas together. So I'm going to start off by labeling the whole thing, and I've just chosen to go like this. So A, B, C, D. And I can actually find the area of ABD without doing any more work. I've just realized that now. I think I've actually done it a different way. Oh no, we're good. Okay, so the first thing we'll do is we'll get the first triangle area found. So area ABD is going to use this angle and the two sides next to it, right? What I call the hugger sides, or the adjacent sides. So it's going to be 1/2 times 26 times 17 times sine of 94 degrees, right? So make sure your calculator at this stage is in degrees mode. And when we work that through, we get 220.46 meters squared. All right, so the next thing we've got to do is we've got to find the area of BCD. So if we look at BCD, we haven't got much information here yet at all. We've got this angle, we've got 85 degrees, and we've got 20 meters here, but we don't have this side, and we don't have any other angles. So I can't use the sine rule yet. So what I need to do, or the way that I did this anyway, is that I figured out what this side length was. And I did that using triangle ABD. So let's draw out triangle ABD, and then we're going to find this side length here. ABD, we've got 26 meters here, 17 meters here, and 94 degrees up here. So we can say, if we call this side A, little a squared is equal to 26 squared plus 17 squared minus 2 times 26 times 17 times cosine of 94 degrees. And that equals 1026.665. Now that's using the cosine rule. Okay, the cosine rule for a side length. That formula is this: a squared plus b squared minus 2bc cos of a. We don't want a squared though, we want a. So that means that we need to have a is equal to the square root of that, which gives me 32.04 meters. And we can label that as little a, or we can call it side BD. Right, so that helps me to figure out the area of the second triangle, because now we've got this side length here and we've got this angle here. So what I need to do to find the area is I'm going to need to work out this side here, or I'm going to need to work out this angle here, right? Because to use the area formula, I need to have two sides and the angle that's included. So we can either get this angle or we can get this side. I'm just trying to remember what I chose to do. Oh, yeah, so I chose to find the angle first. I'll do a better drawing down here. Use a ruler this time. So a nice big triangle. And just label it. So here's C, D, and B. We know that this angle here is 85 degrees. This side is 20 meters, and this side is 32.04 meters. So I'm going to find this angle over here, theta, and I'm going to call that angle B. Or if we want to be more precise, we could say angle CBD. We're going to get this one using the sine rule. So sine theta over 20 is equal to sine of 85 degrees over 32.04. So I'm doing that because I've got an angle in the opposite side, which means that I can work out another angle using the sine rule. That gives me sine of theta is equal to 20 times sine of 85 degrees divided by 32.04, or sine theta is equal to 0.621844. Theta, the angle, is equal to sine inverse of 0.621844, which gives me 38.45 degrees if I'm working in degrees. So now we've got this one and we've got this one, but the two sides that I've got are this one and this one. So to find the area, I need to have this angle. But as I said in class, if you know two angles in a triangle, then you know the third angle. And angle BDE, so that third angle, will be 180, take away this one, take away this one. 180 take away 85, take away 38.45. That gives me 56.55, or it would be fine to say 56.6 degrees. Right, so finally we're ready to do the area of this one here. And we're going to use this, this, and this angle. So the area of triangle BCD is equal to 1/2 times 20 times 32.04 times sine of 56.55 degrees. And when I worked all of that out, I got, so this is 10, 320.4. We end up with 267.3312 meters squared. So the total area is equal to 220.46. I'm rounding a little bit more now, plus 267.33 meters squared, giving me 487.79 meters squared. So that's the first bit of the task done. And you can see we've used a few things, not crazy numbers of things. We've used the cosine rule for a length, we've used the sine rule for an angle, and we've used the area for a triangle twice over. Let's look at what we have to do for the next part. So he's figured out, we're not asked about the perimeter, by the way, we're just asked here about the area, and he's going to do an extension, and that has to be 25% of the total area. So I'm going to do this in another video, but let's just see the kind of thing we're going to be doing. Well, the first thing we're going to have to do is work out how much area the new part of the garden should take up. And then you can start to have a think about how could we make that extension look. We've got quite a few options, but I think the easiest one to see is to whack on an extra triangle down here and it's got to have a particular area. The reason I want to do that is because I know that side length, and I can also work out what this angle here will be, and then I can just bang in another triangle like that. So that's one thing that we think is quite an easy thing to do. And then I'm also going to try and do something a bit more interesting with a circly bit. So they'll be done in the next video. Hopefully this helps. Let me know by email if you've got any questions or if you've found any mistakes in my working. Thanks for watching.